Hello, this is Tano and Winnie Sang. We are with the IBM Cognitive OpenTech Group at the Silicon Valley Lab in San Jose, California. In this journey, we will use deep learning to train an image classification model. We will use data from the art collection at the New York Metropolitan Museum of Arts. The museum hosts some 450,000 art items in its collection. To create the labels, we will use the public table in Google BigQuery. Here on the web console, we can look at the attributes available for each art items. For this journey, we will use the culture attribute as the label. You can use other attributes to classify the art collection, for instance, the author name, the time period, and so on. First, we will run a request to the BigQuery tables to get the list of arts along with the labels. Here we found about 114,000 images with culture labels. Next, we will use this list to download the image of the art pieces from the museum website. We convert the JPEG file into the TF record format so that this TensorFlow code we use. Note that the data has been split up into two sets, one for training and one for validation. Next, we will use IBM Bluemix to bring up a Kubernetes cluster. After logging into Bluemix, browse the catalog to find the Kubernetes cluster service. The light cluster that you can get with the trial account will only give you one worker node with 2 CPU and 4 GB RAM. To launch the TensorFlow container, we will need to build our own Docker image. Then we will register the image with Bluemix. Next, we edit the train model YAML file to update the name of the image and the Bluemix secret key. We launch the pod using Keep Control. Here we can see the pod starting up. After some time, the pod will complete the training. Now we can look at the logs to see the training in progress. To evaluate the model, we edit the eval model YAML file to update the image name and do Bluemix secret, and we launch the pod in the same way. When the pod completes, we check the log again to see the result. Here we see the accuracy is only 25%, which is quite low, and this is because we only ran a very short training for demonstration purpose. To use TensorBoard to visualize the training process, we copy the event log from the Kubernetes volume and start up TensorBoard. On your browser, we go to the link for TensorBoard. Here we are showing the log from a training for some 15,000 steps. For demonstration purpose in this journey, we ran the training on a small Kubernetes cluster, and we select a small set of images and a small number of classes to fit the amount of resource that we have. In typical case, the amount of data is very large, so you will need to use advanced shared storage service such as HDFS or NFS. The training does require a lot of computation resource and can run for days or weeks. You can use GPU to speed up the training. In addition, you can use distributed TensorFlow to scale out on a distributed system. The particular code version we use here today is not yet ready for distributed mode, but we expect it to be running in distributed mode soon.